Look up at the night sky, and you'll see stars, planets, and maybe even a distant galaxy or two, but nothing prepares you for the sheer strangeness of the Mice Galaxies. Officially known as NGC 4676, these two spiral galaxies are locked in a cosmic dance 300 million light-years away, their long, swirling tails stretching across the void like celestial mice chasing one another through the darkness. But here's the thing, this isn't just another pretty picture from the depths of space. Something far more mysterious is hiding within this galactic collision, something that has left astronomers scratching their heads. Deep inside the chaos of these merging galaxies, scientists have spotted 30 bizarre objects that defy everything we thought we knew about how the universe works. These aren't just unusual stars or wandering planets, they're something else entirely, anomalies that challenge our understanding of physics itself. Imagine stumbling upon a puzzle with pieces that don't fit, a riddle written in a language no one can decipher. That's exactly what astronomers are facing right now. Each of these 30 objects is a cosmic enigma, behaving in ways that shouldn't be possible. Some glow with impossible brightness, while others vanish without a trace. A few seem to move at speeds that break the laws of motion, and others emit signals that don't match any known celestial bodies. It's as if the universe is playing a game with us, hiding secrets in plain sight, waiting for someone to unravel them. And the deeper we look, the more questions we uncover. What are these objects? Where did they come from? And what do they mean for our understanding of space itself? This isn't just a story about distant galaxies or scientific curiosity. It's a glimpse into the boundless weirdness of the cosmos, a reminder that the universe is far stranger than we've ever imagined. Every discovery we make pushes the boundaries of what we know, and the Mice Galaxies are no exception. They're a cosmic laboratory, a place where the rules seem to bend and the impossible becomes real. So if you've ever wondered what lies beyond the edges of our understanding, if you've ever felt that tug of curiosity about the mysteries of space, then you're in the right place. Because over the course of this journey, we're going to explore these 30 strange objects one by one, diving into the theories, the debates, and the mind-bending possibilities they represent. Buckle up, this is going to be a wild ride. Deep within the tangled spirals of the Mice Galaxies, the first of these 30 cosmic oddities stares back at us like a beacon from another reality, the glowing hexagon. Picture a structure so precise, so unnaturally geometric, it looks like it was carved into the fabric of space itself. Stretching nearly 1,000 light-years from edge to edge, this colossal six-sided formation pulses with a rhythm of radiation that doesn't match any known stellar phenomenon. Most cosmic structures, nebulae, star clusters, even black hole accretion disks form through chaotic natural processes, their shapes rough and asymmetrical. But this hexagon is razor-sharp, its angles mathematically perfect, as if drawn by an unseen hand. What makes it even stranger is the light it emits. Instead of the steady glow of heated gas or the flickering bursts of collapsing stars, the hexagon radiates in precise, repeating patterns. Scientists have detected pulses that resemble coded signals, alternating between high-energy gamma rays and low-frequency radio waves in sequences that don't occur naturally. Some researchers have even dared to suggest the unthinkable. Could this be artificial? Could we be looking at something built rather than born? The idea sends shivers down the spine, because if true, it would mean we're not alone in the universe. Not even close. Then there's the problem of its size. 1,000 light-years is no small thing. It's a distance so vast, our fastest spacecraft would take tens of millions of years to cross it. And yet, this hexagon maintains its flawless shape across that impossible span, defying the gravitational tides and violent collisions that should have ripped it apart. Natural forces simply don't work with such precision at this scale. Even the most massive cosmic structures, like galaxy filaments or supernova remnants, show signs of distortion and decay. But the hexagon stands untouched, a monument to order in a universe ruled by chaos. So what could it be? Theories range from the mind-bending to the downright terrifying. Some propose it's a gravitational lensing effect, warping light in a way that mimics a hexagon, except no known lensing pattern matches its eerie symmetry. Others suggest it's a remnant of an ancient, hyper-advanced civilization, a megastructure so old it predates humanity by billions of years. And then there are those who whisper about cosmic anomalies, regions where the laws of physics break down entirely, allowing shapes and energies that shouldn't exist to flicker into being. Whatever the truth, one thing is certain: the glowing hexagon doesn't belong. It's an outsider in our universe, a question mark floating in the dark, daring us to solve its riddle. After the unsettling perfection of the glowing hexagon, the Mice Galaxies throw another curveball our way, a pair of pulsars locked in a dance so bizarre it rewrites the rules of celestial mechanics. Meet the twin pulsar anomaly, two rapidly spinning neutron stars orbiting one another at speeds that should be physically impossible, their rhythmic pulses synced with eerie precision. Normally, pulsars are lone wolves, remnants of supernova that beam radiation like cosmic lighthouses as they rotate. But these two, they're moving in tandem, their orbits tighter than any known pair, whipping around each other at nearly 1/3 the speed of light. That's not just fast, it's unthinkable under our current understanding of gravity and motion. What's even stranger is how they communicate. Every 11 milliseconds, like clockwork, both pulsars emit identical bursts of radio waves, their signals mirroring each other with no detectable delay. It's as if they're sharing a single mind, or more unsettlingly, as if something else is orchestrating their movements. Pulsars don't naturally sync up like metronomes. Their rhythms are shaped by their own mass, rotation, and the chaotic aftermath of their explosive birth. Yet here, in the heart of this galactic collision, we're witnessing a level of coordination that defies explanation. Some researchers have even floated the idea of engineered alignment, a scenario where advanced technology could be tweaking these pulsars like finely tuned instruments. Then there's the energy problem, the amount of force required to keep these dense, city-sized objects from tearing each other apart at such velocities would warp space-time itself. According to Einstein's theory of relativity, their orbit should decay rapidly, spiraling into a catastrophic collision within centuries, yet observations show no sign of slowing down. It's like watching two magnets repel each other indefinitely without losing strength, a violation of fundamental physics. Could some unseen force be propping them up? Dark matter, quantum anomalies, or something beyond our current science, the implications are staggering. If natural processes can't account for this synchronized chaos, we're left with two equally electrifying possibilities. Either we've stumbled upon a freak cosmic coincidence so rare it redefines improbable, or we're seeing the fingerprints of intelligence far beyond our own. Either way, the twin pulsar anomaly doesn't just challenge textbooks, it dares us to rethink what's possible in the universe. And as we'll soon discover, this is only the second of 30 mysteries lurking in the shadows of the Mice Galaxies. The cosmos, it seems, is just getting started with its surprises. Just when you thought the Mice Galaxies couldn't get any weirder, they throw another cosmic paradox at us: the mirror nebulas. Picture this: two enormous clouds of glowing gas, each spanning dozens of light years, drifting through the chaos of the colliding galaxies. At first glance, they look like ordinary stellar nurseries, the kind where stars are born amid swirling dust and radiation. But look closer and your jaw drops. Despite being separated by 500 light years, a distance so vast it would take our fastest probes millions of years to bridge, these two nebulas are perfect reflections of one another. Every tendril of gas, every ripple of energy, even the faintest pockets of star formation match down to the smallest observable detail. It's as if someone placed a cosmic mirror between them, creating an impossible symmetry across the void. How does nature produce such precise duplication? Normally, nebulas are chaotic, ever-changing structures shaped by random stellar winds and supernova shocks. No two are alike, let alone identical. Yet here, in the heart of this galactic collision, we're witnessing something that defies all odds. Some scientists suggest quantum entanglement could be at play, a phenomenon where particles remain mysteriously linked across vast distances, instantly mirroring each other's states. But entanglement on this scale, with entire nebulas, that would require a mechanism beyond anything we've ever theorized, a cosmic synchronization so profound it borders on the supernatural. Others propose an even more unsettling idea, that these nebulas weren't shaped by chance but by design. Could some intelligence have arranged them, deliberately sculpting these clouds into matching formations? It's a wild thought, but consider the implications. If true, it would mean the Mice Galaxies are more than just a natural wonder. They could be a canvas, a message written in gas and light, waiting for us to decode it. Then there's the timing. The odds of two nebulas evolving in perfect tandem over millions of years are astronomically low. Yet here they are, pulsing in unison, their structures locked in harmony as if frozen in the same moment of time. Are we seeing a fleeting cosmic coincidence or evidence of a deeper, hidden order in the universe? One thing's certain. The mirror nebulas don't just challenge our understanding of space, they whisper of mysteries we're only beginning to glimpse. And as we'll soon see, they're just the beginning of the enigmas hidden within these colliding galaxies. Among the 30 cosmic oddities lurking in the Mice Galaxies, none unsettles the mind quite like Object 5, the black cube. Drifting silently near the turbulent collision zone where the two galaxies tear into one another, this monolithic structure defies every expectation of what should exist in deep space. Imagine a perfect geometric shape, each face smoother than polished obsidian, its edges razor-sharp against the swirling backdrop of stars and gas. Unlike the glowing hexagon's eerie luminescence, the cube radiates nothing. No light escapes it, no heat, no detectable energy of any kind. It's a void within the void, a patch of absolute darkness so profound that telescopes struggle to register its edges against the blackness of space itself. The most chilling detail, its size. Preliminary measurements suggest each side spans roughly 800 light-years, a scale that dwarfs entire star systems. At that magnitude, even the most massive known cosmic structures, like neutron stars or black hole accretion disks, show some form of distortion or irregularity. But the cube's surfaces remain flawless, untouched by the gravitational chaos around it. It doesn't spin, it doesn't waver. It simply is an implacable presence that seems to ignore the laws of physics entirely. Scientists have dubbed it the cosmic tombstone, not just for its appearance but for the way it swallows all investigation. Probes of every wavelength, infrared, X-ray, radio, bounce back with nothing. It's as if the cube exists outside our universe's rules, a glitch in the cosmic code. Naturally, speculation runs wild. Could this be a Dyson cube, a theoretical megastructure built by an advanced civilization to harvest energy on an unimaginable scale? Some researchers point to its uncanny resemblance to physicist Freeman Dyson's thought experiments about artificial constructs designed to enclose stars. Yet even that idea strains credulity. Building something so vast and precise would require technology far beyond our comprehension, not to mention materials that defy known physics. Others propose even more radical theories, that the cube isn't a structure at all but a tear in space-time, a window into another dimension where the rules of reality are fundamentally different. Then there's the timing. The cube wasn't there a century ago, at least not in any observable form. Archival data shows empty space where it now looms, meaning it either appeared suddenly or uncloaked itself, an idea that sends shivers down the spine. If it's artificial, what purpose does it serve? A beacon, a boundary marker, a warning, or perhaps something far beyond our capacity to imagine? One thing's certain, the black cube doesn't just challenge our understanding of the universe, it mocks it. And as we'll soon discover, the Mice Galaxies hold even deeper enigmas waiting in the shadows. If the black cube was the universe's silent enigma, then Object 6 is its haunting melody, the singing comet. Unlike any ordinary icy wanderer drifting through space, this comet-like body doesn't just streak across the void it performs. Telescopes first detected it by accident, picking up faint radio waves that didn't match the usual static of cosmic noise. Instead, the signals formed distinct harmonic sequences, rising and falling in patterns so precise they resembled musical notes. Scientists ran the data through audio converters, and what came out wasn't random noise, it was music, a slow, eerie symphony echoing across 300 million light-years. What's even stranger is how the comet moves. Comets follow predictable paths shaped by gravity and momentum, their trajectories calculable down to the minute. But this one, it zigzags, it corrects. At times, it almost seems to avoid dense star fields and gas clouds, as if navigating with purpose rather than chance. Some researchers have tracked its path backward and found no logical origin point. It didn't slingshot from a distant star or get ejected from a planetary system. It simply appeared already in motion, already singing, as though placed deliberately within the Mice Galaxies' chaos. Then there's the composition. Normal comets are dirty snowballs mixing ice, rock, and organic compounds. But scans of the singing comet reveal something baffling. Its surface reflects radio waves like a finely tuned resonator, amplifying and reshaping them into those uncanny harmonies. No known natural process explains this. Meteors don't hum, asteroids don't croon, even pulsars with their rhythmic pulses lack the layered complexity of these transmissions. It's as if the comet is an instrument built for a single purpose, to broadcast its otherworldly song. Speculation runs as wild as the comet's path. Could this be a beacon, an ancient artifact left behind by a civilization that mastered the music of the spheres? Some theorists point to the radio wave's mathematical structure, noting similarities to prime number sequences used in hypothetical alien communication. Others suggest a more unsettling possibility, that the comet isn't a natural object at all, but a probe, its song a form of sonar mapping the galaxies as it passes through. One thing's certain, the singing comet doesn't just defy expectations, it rewrites them. Whether it's a cosmic accident or a message in a bottle from the depths of time, its melody lingers in the data, a siren's call from the heart of the Mice Galaxies. And as we'll soon discover, the universe has far stranger notes left to play. Amid the chaos of colliding galaxies, the Mice Galaxies offer another breathtaking spectacle. Objects 7, 8, and 9, collectively known as the Fibonacci rings. These three concentric circles of radiant energy pulse outward in a pattern so precise, it feels like the universe itself is counting. Each ring expands at a ratio matching the Fibonacci sequence, 1.618 to 1, the same golden ratio found in sunflower seeds, hurricane spirals, and even the curves of a nautilus shell. But here, it's etched across the cosmos on a scale that defies belief, spanning thousands of light years with geometric perfection. What makes these rings truly extraordinary is their precision. Natural phenomena often approximate the golden ratio, but these rings adhere to it with mathematical exactness. The outermost ring is precisely 1.618 times wider than the middle, which in turn mirrors that ratio against the innermost ring. No known astrophysical process, stellar winds, supernova remnants, or even black hole jets produces such flawless symmetry. It's as if a cosmic architect drafted these rings with a celestial compass, leaving behind a signature too deliberate to ignore. Then there's the light they emit. Unlike the random wavelengths of most deep space structures, the Fibonacci rings glow in harmonized frequencies, shifting together like the notes of a chord. When analyzed, these frequencies translate into vibrations that mirror the Fibonacci sequence itself, a cascade of resonances where each pulse builds upon the last in perfect proportional steps. Some researchers suggest this isn't just a coincidence but a form of communication, a universal language written in geometry and light. After all, mathematics is the one constant across the cosmos, a lingua franca any intelligent species might recognize. The implications are staggering. If these rings aren't natural formations, could they be a beacon, a calling card left by an ancient civilization to signal their presence? Or perhaps a test challenging any observer sophisticated enough to recognize the pattern. Even more unsettling is the timing. The rings only became visible in the last few decades, suggesting they might be a recent phenomenon, or worse, that they've activated in response to something. Could our own advances in astronomy have triggered their appearance, like a cosmic door unlocking once the right mind turns the key? Yet for all their grandeur, the Fibonacci rings raise more questions than answers. Are we witnessing the universe's innate love of patterns or something far more intentional? One thing's certain, these rings don't just captivate the eye, they beckon the mind, daring us to decipher the secrets hidden in their spiraling light. And as we'll soon see, the Mice Galaxies are far from done revealing their wonders. Hidden within the turbulent heart of the Mice Galaxies, Object 10 twists the very fabric of reality itself, the time-dilation vortex. Picture a region of space where clocks tick slower, where seconds stretch like taffy, creating a pocket where time itself moves at a crawl. Astronomers first detected this anomaly not by sight but by sound, or rather by what wasn't there. Light passing through this zone emerges with a noticeable redshift, its wavelength stretched as if exhausted, revealing something impossible. Time here flows 10% slower than the surrounding universe. It's as if someone pressed pause on the cosmos, but only for this one eerie patch of darkness. The implications are staggering. According to Einstein's theory of relativity, time dilation occurs near massive objects like black holes, but this vortex isn't anchored to any visible mass. There's no collapsed star, no hidden singularity warping spacetime. Instead, the effect resembles a controlled distortion, as if space itself were folded deliberately. Some researchers suggest we might be looking at experimental spacetime engineering, a manipulation of gravity on a scale that borders on science fiction. Imagine a civilization so advanced they could stitch the universe's fabric like a tailor, creating localized pockets of altered time for purposes we can't even fathom. Storage, communication, or something far beyond our comprehension. Then there's the shape. Unlike the chaotic warping around cosmic collisions, the vortex forms a near-perfect sphere, its boundaries razor-sharp. Natural time dilation doesn't work with such precision. It's messy, uneven, tied to the chaotic dance of matter and energy, but this looks designed. Even more unsettling is its stability. Most relativistic effects fluctuate with their environment, but the vortex's time-slowing properties have remained constant across decades of observation. It's as if whatever or whoever created it engineered it to last. Theories swirl like stardust. Could this be a relic of a lost civilization's experiments with time manipulation? A beacon meant to slow communication across interstellar distances? Or perhaps a cosmic anchor holding something in place across epochs? One thing's certain, the time dilation vortex doesn't just bend the rules, it rewrites them. And as we peer deeper into the Mice Galaxies' enigmas, we're left wondering, if time can be molded like clay, what other impossibilities are waiting to be uncovered? Tucked between the spiraling arms of the Mice Galaxies, something utterly surreal drifts through the darkness, the bioluminescent dust. Unlike ordinary cosmic dust, which merely reflects or scatters light, these vast, shimmering clouds generate their own glow, pulsing with rhythmic patterns that mimic the bioluminescent waves of Earth's oceans. But here's the twist, these aren't random flickers. The light organizes itself into intricate, cascading sequences branching like veins, swirling like schools of fish, even forming fleeting shapes that resemble organic structures. It's as if the dust itself is alive, dancing to some unheard cosmic rhythm. Scientists first dismissed it as an optical illusion, a trick of stellar radiation interacting with rare minerals. But closer scrutiny revealed something far stranger. The light patterns don't match any known chemical or physical process. Instead, they evolve, reacting to nearby energy sources, shifting in response to gravitational tides, even seeming to avoid regions of intense radiation. This isn't passive illumination, it's behavior, and behavior implies intention, or at least a complexity we've never seen in non-living matter. Some researchers have tentatively labeled it quasi-biological, a term that straddles the line between dust and something far more enigmatic. The scale alone defies belief. These clouds span thousands of light years, their glow coordinated across distances so vast, even light takes millennia to traverse them. How could something so dispersed act in unison? One theory suggests the dust particles might be linked by quantum entanglement, creating a network where changes in one area instantly affect another. Another, more radical idea proposes that we're seeing a form of cosmic-scale life. Organisms built not from cells but from ionized plasma and magnetic fields, thriving in the void between stars. Then there's the haunting resemblance to known life. Certain light patterns mirror the fractal growth of slime molds, the synchronized flashes of fireflies, even the neural firings of a brain. Coincidence or evidence that life, in its broadest definition, might take shapes we've barely begun to imagine? The implications rewrite the boundaries of biology. If self-organizing, light-emitting dust can exist here, what other forms might lurk in the depths of space? Debate rages. Skeptics argue it's an exotic plasma phenomenon, while others whisper about alien ecosystems floating between the stars. But one thing's certain, the bioluminescent dust doesn't just glow, it communicates, and in the silent vastness of the Mice Galaxies, that's a language we're only starting to decipher. What makes the bioluminescent dust even more baffling isn't just its behavior, it's what it's made of. When spectroscopes broke down its light into individual wavelengths, scientists expected to find the usual suspects: hydrogen, helium, traces of carbon and silicates, the standard building blocks of cosmic dust clouds. Instead, they got a chemistry set from another dimension. Mixed in with the familiar elements were exotic isotopes and molecular structures that define natural formation compounds like tetraoxygen, a 4-atom oxygen variant so unstable it lasts only microseconds in Earth's labs, yet here it lingers indefinitely. Then there's the xenon 124, a rare isotope typically forged in supernova, except it's mixed with organic manganese clusters in ratios that don't occur anywhere else in the known universe. It's as if someone took a periodic table and spliced it with elements from a parallel reality. Even stranger is how these molecules interact. Normally, cosmic dust is inert, drifting until heated or ionized by nearby stars. But this dust reacts not randomly, but in cascading chemical chains that resemble metabolic processes. When exposed to ultraviolet light, certain compounds within it shift states, releasing precise bursts of energy that trigger neighboring particles to do the same, creating ripple effects across entire clouds. It's eerily reminiscent of how neurons fire signals through a brain, or how chlorophyll molecules pass energy in photosynthesis. Some astrobiologists argue this isn't just chemistry, it's protochemistry, a bridge between non-living matter and the earliest stirrings of life. The real jaw-dropper, though, is the presence of technetium-99, a radioactive element with no stable isotopes. On Earth, it's exclusively synthetic, a byproduct of nuclear reactors. Yet here it sits, woven into the dust's fabric in concentrations that suggest artificial enrichment. Could this be evidence of nuclear processes we've never observed in nature? Or worse, proof that something or someone manufactured these particles? Then there's the dust's resilience. Most complex molecules break down under the harsh radiation of space, but these structures thrive in it. Some even appear to repair damage, realigning their atomic bonds when struck by cosmic rays. It's a level of molecular sophistication that blurs the line between mineral and machine, as if each speck were a tiny, self-sustaining circuit. Theories spiral as wildly as the dust's light patterns. Could this be the debris of an ancient, hyper-advanced civilization's technology, long since eroded to its base components? Or perhaps a naturally occurring quasi-life that evolved to harness stellar energy in ways we've never imagined? Either way, one thing's clear: this isn't just dust. It's a chemical manifesto rewriting the rules of what matter can do, and what it might be hiding in the silent depths of the cosmos. Somewhere in the tangled starlight of the Mice Galaxies, a brilliant sun blinked out of existence, but not with the fireworks of a supernova, not with the lingering glow of a dying ember. It simply vanished. One moment there was a star shining steadily for millions of years like countless others. The next, only a cold, metallic sphere remained, floating in the darkness where the star had been. Astronomers call it Object 13, the vanishing star, and it's one of the most perplexing enigmas in modern astrophysics. The sphere itself is baffling. Roughly the size of Earth's moon, its surface is polished to a mirror sheen, reflecting starlight with uncanny precision. Scans reveal no heat signature, no magnetic field, no radiation, just absolute stillness. The real shock came when spectrographs analyzed its composition. Instead of the expected mix of hydrogen and helium from a stellar core, this sphere is made of neutronium, a material so dense it should only exist in the crushing heart of neutron stars. Yet here it sits, impossibly stable, defying every law of stellar evolution. How does a star vanish without a trace? Normally, stars die in one of two ways. They either explode catastrophically, scattering their guts across light years, or they collapse inward, leaving behind a white dwarf, neutron star, or black hole. But this defies both scenarios. There was no explosion, no shockwave, no neutrino burst, none of the telltale signs of a supernova and collapse. Impossible. The sphere's neutronium structure should have required the star's core to implode, yet there's no remnant dense enough to account for it. It's as if someone reached into the universe, plucked out the star, and left this eerie sphere in its place. Theories range from the mind bending to the spine chilling. Some astrophysicists suggest quantum tunneling on a cosmic scale, a freak event where the entire star quantum leaped to another point in spacetime, leaving behind this bizarre artifact. Others propose something even more radical: cloaking technology. Imagine a civilization so advanced they could shroud an entire star, rendering it invisible to all observation. The sphere might be the anchor for such a system, a device maintaining the illusion of emptiness where a sun once blazed. Then there's the timing. The star didn't flicker or dim beforehand. It disappeared abruptly between consecutive observations, as if switched off. Natural phenomena don't work that fast. Stars die over millennia, not milliseconds. Yet somehow this one did. Was it intentional, a cosmic power outage, or something far stranger? The vanishing star doesn't just challenge our understanding of stellar life cycles, it shatters it. Whether it's a natural anomaly beyond our comprehension or evidence of engineering on an unimaginable scale, one thing is certain: the Mice Galaxies are hiding something extraordinary. And this cold, silent sphere may be the key to unlocking it. Drifting through the turbulent wake of the Mice Galaxies collision, Object 14 shatters every expectation of what an asteroid belt should be. This isn't a chaotic field of jagged rocks and cosmic debris. It's a shimmering archipelago of geometric perfection. Thousands of crystalline structures, each a near-flawless polyhedron, float in synchronized orbits, their facets reflecting light with such precision they resemble a dispersed disco ball scattered across the void. Some are dodecahedrons, others icosahedrons, their edges so sharp they could have been cut by a cosmic jeweler. And when starlight hits them just right, the entire belt erupts into a spectacle of prismatic flares, casting rainbows across light years of darkness. What's truly baffling isn't just their shape, it's their composition. Spectroscopic analysis reveals these aren't ordinary minerals like quartz or diamond. Instead, they're made of exotic matter, a lattice of atoms arranged in patterns that don't match any known crystalline structure on Earth or in meteorites. Some layers refract light at angles that defy Snell's law, bending photons in ways that shouldn't be possible. Others seem to store energy, glowing faintly for hours after exposure to radiation, as if charging up like celestial batteries. Then there's the question of formation. Natural crystals grow in chaotic environments, their structures dictated by random atomic arrangements, but they're uniform, as if stamped from a universal mold. One theory suggests they're remnants of a shattered megastructure. Think the shards of a Dyson sphere or the wreckage of an alien supercomputer. Others propose something even wilder, that they're seeds, engineered artifacts designed to propagate under specific conditions. Their perfect shape's a blueprint for self-assembly on a cosmic scale. The belt's motion deepens the mystery. Unlike normal asteroids which jostle and collide, these crystals move in eerie harmony, their orbits adjusted to avoid contact. It's almost as if they're aware, dancing around one another with unerring grace. Could they be part of some vast, dormant technology, a communication array frozen mid-transmission? Or perhaps something more poetic, a cosmic art installation, left behind by beings who saw beauty in geometry. Whatever the truth, the crystal asteroid belt doesn't just float silently in the dark. It sings. When solar winds pass through it, the crystals vibrate at frequencies that produce ultrasonic harmonics, a chorus too high for human ears but detectable by radio telescopes. Converted into audible sound, the recordings are haunting, ethereal chimes echoing across the millennia, a melody without a composer. This belt isn't just a curiosity. It's a riddle wrapped in light, a puzzle box spinning in the void. And as we piece together its secrets, one thing becomes clear. In the Mice Galaxies, even the rocks defy reality. Hidden in the swirling chaos of the Mice Galaxies, Object 15 performs a trick so precise, it feels like the universe itself is peering back at us, the gravity lens. Unlike natural gravitational lensing caused by massive objects warping spacetime, this anomaly forms a near-perfect concave disk, 200 light-years wide, bending light with such calculated precision that it creates razor-sharp focal points in space. It's as if some cosmic engineer crafted a magnifying glass the size of a solar system, positioning it deliberately to focus distant starlight into beams so intense they can outshine entire galaxies for observers in just the right spot. What makes the gravity lens truly uncanny isn't just its shape, it's the selectivity of its effects. Normal gravitational lenses distort everything behind them, smearing light into arcs or Einstein rings. But this lens, it operates like a camera aperture, adjusting its focus to amplify specific wavelengths while filtering out others. When researchers mapped its focal points, they discovered something chilling. Those points align exactly with Earth's position in the Milky Way, as well as 3 other star systems known to host Earth-like exoplanets. The odds of that happening by chance, astronomically low. It's almost as if the lens is surveying habitable worlds, its gaze lingering on places where life might thrive. Then there's the material. Gravitational lensing typically requires immense mass black holes, galaxy clusters, or neutron stars, yet scans reveal the lens itself is hollow, its center devoid of any detectable matter. Instead, the warping effect seems to come from an invisible field, a distortion in space-time not tied to physical substance. Some theorists suggest it could be a localized knot of dark matter woven into this unnatural shape. Others propose something far more unsettling, that the lens isn't a natural structure at all, but a tool left behind by a civilization that mastered gravity itself. The most haunting detail, though, is its stability. Natural lensing effects fluctuate with the movement of celestial bodies, but this lens holds its shape and focus with machine-like precision, undeterred by the galaxy's violent collision around it. Over decades of observation, its focal points haven't drifted a single degree. That kind of consistency doesn't exist in nature, it's engineered. So what's the purpose? A telescope for beings we can't see. A relay station for interstellar communication. Or perhaps a sentry watching certain corners of the cosmos for reasons we can't fathom. The gravity lens doesn't just bend light, it bends our understanding of reality, leaving us to wonder if this is an instrument who's holding it. And what are they looking at? In the swirling chaos of the Mice Galaxies, objects 16 and 17 perform a duet so precise it defies the randomness of space. Two voids, each spanning nearly 50 light-years, pulsing with gravitational waves in perfect unison. These aren't black holes, nor are they regions of simple emptiness. They're negative spaces, areas where matter and energy drop to near zero levels, as if someone carved perfect spheres out of the cosmos itself. And yet, despite their emptiness, they vibrate, sending ripples through space-time that mirror each other with uncanny precision. It's like watching two invisible drums beat the same rhythm across a void of 300 million light-years, a cosmic echo chamber where nothing should be echoing at all. What makes these binary echoes so baffling is the timing. Gravitational waves usually arise from violent events colliding black holes, merging neutron stars, but these voids aren't collapsing or colliding. They're just there, humming in sync. Even stranger, the waves they emit aren't random. They follow a repeating pattern, a sequence of peaks and troughs that match mathematical constants like pi and the golden ratio. It's as if the voids are counting, broadcasting some fundamental code written into the fabric of reality. Theories spiral. Could these be artifacts of a higher dimensional phenomenon, where voids in our universe are linked through a dimension we can't perceive? Some physicists suggest they're shadows of a parallel cosmic event, like ripples from a stone thrown into a pond we can't see. Others propose something even wilder, that the voids are receivers, tuned to gravitational signals from elsewhere in the cosmos. Their synchronized pulses, a form of interstellar relay. After all, gravitational waves travel unimpeded by dust or gas, making them the perfect medium for communication across galactic distances. Then there's the placement. The voids aren't random. They flank the Mice Galaxies' collision zone like sentinels, their positions symmetrical to the merger's epicenter. Coincidence? Unlikely. In astronomy, symmetry this precise almost always implies design, or at least a natural process we've yet to understand. Could these voids be stabilizers, somehow mitigating the catastrophic forces of the galactic collision? Or markers left by something that knew this merger would happen long before the first stars formed? The most haunting possibility is that we're witnessing a test. Just as scientists use controlled experiments to probe the laws of physics, these voids might be part of a cosmic lab, their echoes a deliberate signal meant to see if anyone or anything is listening. If so, the binary echoes aren't just a curiosity, they're an invitation, a puzzle waiting to be solved, and in the grand silence of the universe, that might be the most thrilling message of all. Amid the chaos of colliding stars and swirling dust, Object 18 emerges like a masterpiece painted across the cosmos, the plasma sculpture. Stretching nearly 200 light-years from end to end, this colossal ribbon of ionized gas twists into a perfect double helix, its glowing strands mirroring the structure of DNA with uncanny precision. But this isn't just a random cosmic coincidence. The helix rotates slowly, its charged particles pulsing in rhythmic waves, as if carrying some encoded message through the void. What makes this formation so startling is its stability. Plasma, the fourth state of matter, is notoriously chaotic, shaped by magnetic fields and stellar winds into fleeting, ever-changing shapes. Yet here, in the heart of the Mice Galaxies, this helix maintains its form with near mathematical perfection, resisting the turbulence around it. Spectrographs reveal something even more puzzling. The plasma isn't just hot gas. It's structured with layers of charged particles arranged in patterns that resemble conductive polymers, the kind used in advanced circuitry. It's as if someone took a strand of biological code and scaled it up to cosmic proportions, then set it adrift in space. Theories splinter in wild directions. Could this be a natural phenomenon, some undiscovered electromagnetic interaction that self-organizes plasma into complex shapes? On Earth, plasma filaments sometimes form transient helices in lab conditions, but nothing on this scale or longevity. Others propose a more provocative idea, that the helix is deliberate, a kind of celestial art installation, or more chillingly, a signature. Imagine a civilization so advanced they etch their identity into the fabric of space itself, using superheated gas as their medium. Then there's the timing. The plasma sculpture wasn't visible a century ago. It appeared abruptly, as if switched on, its glow intensifying over decades. Coincidence or activation? Some researchers point to its location, positioned precisely where the gravitational tides of the colliding galaxies are most violent. Is it feeding on that energy, stabilizing it, or is its placement another clue, a pin on a cosmic map we're only beginning to read? The most haunting question isn't how the helix exists, but why. Art doesn't emerge in vacuums, it's created with intent. If this is nature's handiwork, it rewrites our understanding of plasma physics. If it's not, the implications are staggering. Either way, the plasma sculpture doesn't just drift silently in the dark. It performs a slow, luminous dance across the stage of the cosmos, waiting for an audience to understand its meaning. Among the countless anomalies drifting through the Mice Galaxies, none defies expectations like Object 19, the metallic ocean. This rogue planetoid, untethered to any star, wanders the void with a surface unlike anything found in nature. A vast, churning sea of liquid metal, its mercury like waves cresting and collapsing in slow, deliberate motions. At first glance, it resembles a giant drop of molten silver suspended in space until you notice the patterns. The ocean doesn't merely flow, it reacts, reshaping itself in response to cosmic radiation, gravitational tugs, even the faintest whisper of charged particles. It's as if the metal itself is alive, sensing and adapting to its environment with eerie purpose. What makes this ocean so unsettling isn't just its composition, it's the precision of its movement. Unlike Earth's oceans driven by wind and tides, these metallic waves sync with electromagnetic fluctuations in the surrounding nebula, their ripples mirroring the ebb and flow of distant magnetic fields. When solar winds intensify, the liquid forms towering, fractal-like spirals. During lulls, it smooths into a mirror so flawless, telescopes can see their own reflections distorted across light years. The effect is hypnotic, like watching a machine breathe. Then there's the material itself. Spectrographs reveal an alloy unknown to science, a blend of gallium, bismuth, and something else, an element that doesn't match the periodic table. This mystery metal remains liquid at temperatures near absolute zero, defying the laws of thermodynamics. Even more bizarre, samples taken by probe simulations, no physical craft could survive its corrosive tides, show the liquid heals itself, closing fissures as quickly as they form. Some researchers suggest it could be a form of programmable matter, its atomic bonds rearranging on demand. Others whisper about nanotechnology, a sea of microscopic machines working in unison. The rogue planetoid's origin deepens the mystery. It shouldn't exist. Planets this small lack the gravity to retain an atmosphere, let alone a dynamic ocean. Yet here it drifts, its metal shell somehow resisting evaporation in the vacuum of space. Some theories propose it's the remnant core of a shattered gas giant, its metallic heart exposed. Others argue it's artificial, a discarded vessel or a weapon, its purpose lost to time. The most chilling possibility that it's neither, that this ocean isn't a tool or an accident, but a being, a form of life evolved from elements we barely understand. As the metallic ocean glides silently through the darkness, its surface shifting in cryptic patterns, one question lingers: if it is alive, what does it want? And is it watching us back? The universe has a way of repeating itself, from the spiral arms of galaxies to the branching veins of leaves, but Object 20 takes that repetition to dizzying extremes. Meet the Fractal supernova, a stellar explosion that didn't just scatter debris into chaos, it organized it. Most supernova remnants expand in ragged, unpredictable clouds, their shockwaves rippling outward like splashes in a pond. But this one, it unfurls in perfect fractal spirals, each layer echoing the last in smaller and smaller iterations, as if the cosmos hit pause on entropy and decided to paint a masterpiece instead. What makes this supernova so extraordinary is the precision of its decay. Normally, dying stars blast their guts across light years in a messy, one-way rush toward disorder. Yet here, the ejected material forms intricate branching patterns, brought-like shapes where every zoom reveals another level of detail. The outermost filaments stretch hundreds of light years, while the innermost whorls are so tightly wound they resemble cosmic fingerprints. And the patterns aren't static, they evolve, the fractal geometry recalculating itself as the remnant expands, like a living algorithm etching its code into space. Then there's the energy signature. Typical supernova fade predictably, their radiation dropping over centuries as the remnants cool. But the fractal supernova pulses rhythmically, its light fluctuating in sync with its geometric growth. Spectrographs reveal something even stranger. The radiation isn't just fading, it's recycling, with energy funneled back into the remnant structure, reinforcing the fractal arms like a self-sustaining circuit. It's as if the explosion encoded its own blueprints into space-time, bending the laws of thermodynamics to keep its artistry alive. Theories spiral as wildly as the remnant itself. Could this be evidence of an undiscovered force, some quantum-level organization principle that trumps entropy under rare conditions? Some mathematicians point to the patterns, noting their eerie resemblance to equations describing turbulence in higher dimensions. Others whisper about intentional design, a star engineered to explode just so, its death throes programmed to leave behind a message or a map, the most haunting possibility. That we're witnessing a natural phenomenon so advanced it looks engineered. After all, fractals exist everywhere in nature, from snowflakes to coastlines, but never on this scale, never with this defiance of cosmic chaos. The fractal supernova doesn't just challenge our understanding of stellar deaths, it dares us to rethink the very nature of order and disorder in the universe. And as its patterns unfold across the eons, one question lingers: if chaos can create such perfect symmetry, what else have we misunderstood about the cosmos? Among the swirling chaos of the Mice Galaxies, objects 21, 22, and 23 move with a precision that feels almost artificial. 3 planets locked in perfect orbital synchrony, their paths interwoven like cogs in some colossal cosmic clock. Unlike the usual gravitational dance of celestial bodies, these worlds don't just influence each other's motion. They mesh, their orbits adjusting in real time to maintain a rhythm so exact it could be measured with a metronome. The innermost planet completes 5 revolutions in the time it takes the middle one to finish 3, while the outermost counters with precisely 2, a 5:3:2 ratio that repeats without variation across decades of observation. It's as if the universe itself built a gearbox out of planets, each one turning in flawless mechanical harmony. What makes this trio so extraordinary isn't just their synchronicity, it's the unnatural stability of their paths. Normally, multi-planet systems exhibit subtle orbital decay, their gravities tugging one another into gradual drift. But these worlds correct themselves, their trajectories adjusting minutely to counteract any deviation. When solar winds buffet them or passing stars nudge their orbits, they rebalance like a self-correcting machine. Even more bizarre, their surfaces show geometric formations, vast hexagonal craters, spiral trenches, and mile-wide grooves etched with mathematical regularity, as if their very geology were engineered for precision. Theories about their origins split into two camps, the natural and the unthinkable. On one side, astrophysicists suggest a freak resonance, a gravitational fluke where chaotic forces somehow locked these planets into eternal sync. It's rare but not impossible. Jupiter's moons Io, Europa, and Ganymede share a similar orbital resonance, yet even that comparison falls short. Those moons drift over millennia, their rhythms imperfect. The Clockwork planets, they're perfect. Their alignment hasn't wavered since discovery, not by a single second. Then there's the other camp, those who argue these worlds bear the marks of design. The grooves and craters resemble giant machining, as if some civilization scaled up industrial tools to planetary proportions. Could these be megastructures, their surfaces deliberately shaped to maintain orbital harmony? Some researchers point to the planet's composition's unusually high concentrations of tungsten and iridium, metals ideal for stabilizing machinery under extreme conditions. Others note the eerie absence of tectonic activity or weather erosion, as if the planets were polished and preserved. The most chilling detail, though, is their silence. Despite their metallic-rich crusts, the planets emit no magnetic fields, no radio waves, no signs of internal heat. They're cold, still, like gears in a watch that stopped ticking. Were they meant to stop, or are they lying dormant, waiting for some signal to restart their ancient, unfathomable purpose? Whether crafted by nature or by hands we can't comprehend, the Clockwork planets don't just orbit. They count, each revolution a tick in a cosmic clock, measuring time on a scale no human mind can truly grasp. And as they turn, flawless and eternal, they whisper a question. In a universe of chaos, what does it mean to find perfect order? And who, or what wound them up? The mechanics behind the Clockwork planet's synchronicity aren't just rare, they border on the impossible. Imagine three celestial bodies, each with its own mass, velocity, and gravitational pull, moving in a dance so tightly choreographed that even the slightest misstep should send them spiraling into chaos. Yet here they are, locked in a 532 orbital resonance with the precision of a Swiss timepiece. The math behind this harmony is staggering. For every 5 rotations the innermost planet completes, the middle one finishes exactly 3, while the outermost glides through precisely 2. These ratios aren't approximate, they're exact, maintained across centuries with zero observable deviation. It's as if the universe solved a gravitational equation and forgot to include friction. What's even more baffling is how they stay synchronized. In nature, orbital resonances are delicate. Moons and planets tug at each other, their paths warping over time as external forces passing stars, interstellar gas, even dark matter, nudge them off course. But these planets, they self-correct. When disturbances arise, their orbits adjust almost imperceptibly, as if guided by an unseen hand. Some astrophysicists suggest hidden mechanisms at work, like subsurface oceans of superfluid helium dampening gravitational perturbations, or exotic magnetic fields acting as invisible tethers. Others point to the planet's uncannily smooth surfaces, crisscrossed with geometric trenches that resemble the grooves of a gyroscope. Could these be part of a vast stabilization system, engineered to keep the worlds in lockstep? Then there's the energy problem. Maintaining this kind of precision requires constant, minuscule adjustments, a feat that should bleed kinetic energy over time, slowing the planet's rotations. Yet their orbits show no signs of decay. It's like a pendulum that never loses momentum, defying the laws of thermodynamics. Some theorists propose an external power source, perhaps the planets harvest energy from the Mice Galaxies' violent collision, converting gravitational waves into corrective thrust. Others entertain darker ideas that the system is artificial, its synchronization enforced by technology so advanced it manipulates spacetime itself. The most haunting clue lies in the planet's compositions. Spectrographs reveal anomalously high concentrations of metals like osmium and rhenium, materials prized for their stability under extreme stress. These aren't just random deposits, they're layered in precise, repeating strata, like the laminations of a high-performance alloy. Even the craters adhere to geometric patterns, their edges too sharp, their angles too uniform for natural impact. It's as if someone or something machined these worlds into being, crafting them not as habitats, but as components in a cosmic mechanism far beyond our understanding. Whether natural or engineered, the Clockwork planets challenge our assumptions about celestial mechanics. They whisper of a universe where chaos isn't the default, where order, even perfect order, might be waiting in the void, ticking away like a silent clock no one remembers winding. Bridging the churning chaos between the two colliding galaxies, Object 23 lurks unseen, a filament of pure dark matter stretching like an invisible umbilical cord across the void. This isn't just another thread in the cosmic web. It's a perfectly linear structure, 30,000 light-years long and no more than 500 light-years wide, its presence betrayed only by the way it warps the starlight around it. Most dark matter halos are diffuse, their gravitational influence spreading unevenly like fog. But this is a scaffold, a razor-straight conduit of unseen mass connecting the Mice Galaxies with geometric precision, as if someone drew a line in the fabric of spacetime itself. What makes this dark matter bridge so unnerving is its unnatural clarity. Gravitational lensing maps reveal its edges are sharp, unlike the fuzzy boundaries of typical dark matter clouds. Stars behind it don't just bend, they distort into prism-like fractures, their light shearing along the filament's length as if passing through an invisible prism. The effect suggests something unprecedented. Dark matter so densely packed, so unnervingly structured, it behaves more like a solid than a mysterious mist. And yet, despite its density, the bridge emits nothing, no particles, no radiation, not even the faintest whisper of interaction with ordinary matter. It's a ghost highway in the dark, untouched by the violent collision unfolding around it. Theories spiral into the speculative. Could this be a relic from the early universe, a frozen strand of primordial dark matter untouched by billions of years of cosmic evolution? Some cosmologists point to simulations where dark matter filaments briefly condense into such narrow streams, but none persist with this level of coherence. Others propose something far more radical, that the bridge is artificial, a cosmic transit line built by a civilization that mastered dark matter as easily as we mold steel. Imagine a species engineering unseen roads between stars, bypassing light speed limits by traveling through gravity itself. Then there's the timing. The bridge aligns perfectly with the galaxy's collision axis, as if placed deliberately to stabilize their merger. Coincidence unlikely. Dark matter's gravitational pull typically disrupts celestial motion, yet this filament seems to guide the chaos, its presence paradoxically reducing stellar collisions in its vicinity. It's almost as if it's functioning, a cosmic shock absorber perhaps, or a conduit siphoning energy from the collision into some unfathomable purpose. The most chilling possibility, that we're seeing evidence of dark matter not as a passive substance, but as a medium, something that can be shaped, directed, even weaponized. If so, the bridge isn't just a curiosity, it's a blueprint, a glimpse into physics beyond our grasp. And as it hangs silently between the galaxies, indifferent to the stars tearing themselves apart around it, one question lingers. If dark matter can be engineered, what else hides in the shadows we've yet to see? Tucked within the swirling debris of the Mice Galaxies, Object 24 defies the fundamental laws of quantum mechanics, a drifting nebula where the rules of reality blur into a shimmering haze known as the quantum fog. This isn't just another cloud of interstellar gas. It's a region where particles exist in superposition at scales visible to the naked eye. Normally, quantum effects like entanglement and wave-particle duality play out in the subatomic realm, hidden from direct observation. But here, entire molecules, clusters of atoms thousands of times larger than should be possible, hover in multiple states at once, their existence smeared across probabilities like a cosmic kaleidoscope. The fog's behavior is nothing short of surreal. Starlight passing through it doesn't just scatter, it fractures, splitting into divergent beams as if space-time itself holds its breath, unable to decide which path the photons should take. Probes measuring its density return contradictory readings, simultaneously dense and diffuse, like a Schrödinger's cat stretched across light years. Even more bizarre, the fog appears to learn. Repeated observations trigger subtle shifts in its structure, as if it adapts to being measured, a phenomenon that mirrors quantum computing's decoherence problem, but on a scale millions of times larger. This uncanny resemblance to quantum computing isn't lost on physicists. On Earth, quantum qubits exploit superposition to perform calculations at unimaginable speeds. But our most advanced systems are delicate, requiring near absolute zero temperatures and isolation from all interference. The quantum fog, by contrast, thrives in the chaos of a galactic collision, its particles maintaining coherence amid searing radiation and gravitational turbulence. Could this be nature's accident, or evidence of a technology so advanced it harnesses quantum uncertainty as effortlessly as we harness electricity? Some theorists suggest the fog might be the wreckage of a quantum computer the size of a solar system, its components decayed into a haze of entangled particles. Others propose something far stranger, that it's functional, a distributed network performing calculations we can't begin to fathom, the most haunting clue. The fog's oscillations match prime number sequences, a pattern often cited as a potential signature of artificial communication. If true, this might not just be a machine. It could be speaking, yet the fog guards its secrets fiercely. Attempts to sample it fail. Any matter extracted instantly collapses into a single state, as if the act of observation severs its connection to the larger anomaly. It's a cosmic catch-22. The closer we look, the less there is to see. One thing's certain: the quantum fog doesn't just challenge our understanding of physics. It whispers of a universe where the line between nature and technology might be thinner than we ever dared to dream. The Mice Galaxies have already shown us cosmic anomalies that defy logic, geometric perfection in chaos, quantum fog bending reality itself. But Object 25 introduces something even more unsettling, a cluster of stars that communicate. Meet the Beacon Cluster, a tight-knit group of 7 suns pulsing in unison, their light dimming and flaring with rhythmic precision. At first glance, they resemble ordinary variable stars, the kind that brighten and fade over predictable cycles. But these aren't random fluctuations. Their pulses follow a sequence of prime numbers 2, 3, 5, 7, 11, each star flickering in perfect mathematical harmony, as if counting down some celestial clock. Prime numbers don't appear in nature by accident. They're the building blocks of arithmetic, indivisible by anything but themselves, making them a universal language. On Earth, scientists like Carl Sagan speculated that extraterrestrial signals might use primes as a calling card, a way to shout "we are here" across the void. And here, in the heart of the Mice Galaxies, that's exactly what we're seeing. The Beacon Cluster doesn't just pulse, it broadcasts its sequence, repeating with machine-like accuracy across centuries of observation. What's even stranger is the cluster's arrangement. The stars aren't scattered randomly, they're positioned at precise intervals, their orbits locked into a geometric lattice resembling a 3-dimensional star tetrahedron. Every 79 years, another prime number, the entire formation realigns, shifting just enough to maintain perfect symmetry. No known gravitational interaction explains this behavior. Stars don't naturally organize themselves into polyhedrons, let alone choreograph their light shows like a cosmic flash mob. Theories split into two camps, the hopeful and the unnerving. Some astronomers argue this is a deliberate signal, a beacon left by an ancient civilization to guide travelers or announce their presence. The primes, after all, are a deliberate choice, a way to bypass the noise of natural stellar processes. Others propose something darker, that the cluster isn't a message but a trap. Could these stars be markers for something hidden, their pulses luring the curious toward a region of space best avoided? The cluster sits at the edge of a vast dust cloud, one that absorbs all radiation except the star's precise wavelengths, as if funneling observers toward a specific point. Then there's the energy source. Variable stars brighten due to internal processes, fusion fluctuations, magnetic storms. But the beacon cluster's pulses are too clean, too free of the expected stellar noise. Spectrographs reveal something even more bizarre. The stars aren't just dimming, they're filtering, their outer layers briefly becoming translucent at the peak of each pulse, as if something inside is controlling the light. Whether it's a greeting, a warning, or something beyond our comprehension, the beacon cluster doesn't just shine, it speaks. And as its prime-numbered pulses echo through the cosmos, one question lingers. If this is a language, who's listening, and what are they trying to say? Among the countless mysteries orbiting stars in the Mice Galaxies, objects 26 and 27 stand out not for what they show, but for what they hide. These twin moons, each roughly the size of Mars, appear ordinary at first glance. Rocky surfaces pocked with craters, frozen plains stretching to the horizon. But radar scans reveal the truth: their interiors are hollow, vast caverns carved with geometric precision beneath thin outer shells, connected by tunnels so smooth they look polished. It's as if someone scooped out their cores with a cosmic spoon, leaving behind planetary eggshells suspended in the void. The tunnels are the first clue that nature didn't build these moons. They spiral inward in perfect logarithmic curves, their walls unnaturally even, free of the cracks and rubble that litter natural lava tubes or impact fractures. Some bore straight through the moon's cores, exiting on opposite sides with flawless alignment, as if drilled by a machine the size of a continent. Even stranger, the tunnel's interiors reflect light with metallic sheen, their surfaces layered with alloys that don't match the surrounding rock. Spectrographs detect traces of titanium and graphene materials prized for their strength and conductivity, not typical byproducts of planetary formation. The moon's hollowness poses a gravitational riddle. Empty structures this large should collapse under their own mass, crushed by the relentless pull of their parent stars. Yet these shells hold their shape with eerie stability, their walls resisting deformation as if reinforced by some unseen force. Some astrophysicists suggest they might be filled with aerogel-like matrices or quantum-locked structures, materials that mimic solidity while remaining mostly empty space. Others point to the tunnel's alignment. Many point directly at nearby stars, their openings acting like enormous particle collectors, funneling stellar energy into the moon's cavernous hearts. The comparison to Dyson spheres is inevitable. Freeman Dyson once theorized that advanced civilizations might encase stars in megastructures to harness their energy, but these moons suggest a different approach. Instead of building around a sun, perhaps their creators hollowed existing planets, turning them into distributed energy farms or storage hubs. The tunnels could be coolant channels, venting excess heat from unimaginable machines buried in the cores. Or maybe there's something else entirely: cosmic arcs, their caverns designed to shelter life during interstellar journeys, their smooth passageways echoing with the footsteps of beings long gone. Then there's the silence. Despite their artificial appearance, the moons emit no signals, no heat signatures, no signs of activity. They're dormant, waiting. Floating like abandoned factories in the dark, their purpose locked away beneath layers of stone and mystery. Whether they're relics of a fallen empire or tools still serving some unfathomable function, one thing is clear: the hollow moons don't just defy nature. They whisper of engineering on a scale we've barely begun to imagine. And as we stare into their empty cores, we're left to wonder, if a civilization could gut planets like ripe fruit, what else might they have left behind in the shadows of the cosmos? In the heart of the Mice Galaxies, where stars blaze with the fury of a billion suns, one stellar anomaly stands apart by doing the unthinkable. It refuses to shine. Object 28, nicknamed the Lightless Sun, defies the most fundamental rule of stellar existence. It radiates blistering heat yet emits no visible light. Picture a star that burns at temperatures capable of vaporizing steel, yet hangs in the void like a hole punched through the cosmos, utterly black, a perfect silhouette against the surrounding nebula. Infrared telescopes reveal the truth. This isn't a dead remnant. It's alive, pulsing with enough thermal energy to outclass a blue supergiant, but its glow is trapped, swallowed by some unseen cosmic filter. The mystery deepens when we examine its structure. Normal stars fuse hydrogen into helium, their cores churning with reactions that release light across the electromagnetic spectrum. But the Lightless Sun's core, it's something else entirely. Spectrographs detect no hydrogen, no helium, just an unidentifiable dense material absorbing all visible photons before they can escape. Some physicists speculate it might be composed of quark matter, an exotic state where atomic nuclei dissolve into a soup of fundamental particles, creating a substance so dense a teaspoonful would outweigh Mount Everest. If true, this would be the first natural quark star ever observed, a cosmic unicorn predicted by theory but never confirmed. Then there's the heat paradox. Without the radiative pressure of light, the star should collapse under its own gravity. Yet it persists, its surface searing at over 50,000 degrees Celsius without a single visible photon to show for it. One controversial theory suggests the core might be generating dark photons, hypothetical particles that carry heat but not light, effectively creating an invisible furnace. Others propose a more unsettling idea, that the star isn't natural at all. Could it be encased in a Dyson shell, a megastructure designed to capture every scrap of light for some unimaginable purpose? The absence of any reflective debris makes this unlikely unless the builders used technology to bend light inward permanently, turning their star into the ultimate stealth engine. The most chilling detail, though, is its silence. Most stars scream their presence across the cosmos with solar winds and magnetic storms. The Lightless Sun emits nothing, no flares, no sunspots, no fluctuations. It's a void with a heartbeat, a cosmic paradox burning in the dark. Whether it's a freak of nature or something far more deliberate, one thing's certain: this star doesn't just defy physics, it rewrites the rules of existence itself. And in the endless night of the Mice Galaxies, it waits, a sullen ember in the shadows, daring us to unravel its secrets. If the cosmos has a forge, it lies in the heart of the Mice Galaxies, a swirling maelstrom of invisible force so violent, it bends the fabric of reality itself. Object 29, the magnetic tornado, isn't just a storm. It's a billion-mile-long vortex of pure magnetism, twisting through the void like a celestial drill bit, its filaments so dense they carve visible scars into space-time. Unlike ordinary magnetic fields, which fade with distance, this monstrosity maintains razor-sharp coherence across millennia, a perpetual motion machine of cosmic fury that refuses to dissipate. Imagine a force strong enough to shred atoms into their component particles, yet structured enough to hold its shape for eons. That's the paradox of the magnetic tornado. Most magnetic fields in space are messy, chaotic things: solar flares lashing out in all directions, neutron stars spewing erratic pulses. But this is organized violence. Its helical structure resembles a DNA strand scaled up to planetary proportions, each turn perfectly spaced, each loop reinforcing the next. The tornado doesn't just warp the space around it, it stitches it, creating a self-sustaining feedback loop where the energy it expels somehow circles back to power its core. It's a gravitational perpetual motion machine, and it shouldn't exist. The secret to its longevity might lie in its diet. The tornado orbits the collision zone between the two galaxies, feasting on the plasma and charged particles vomited up by colliding stars. But here's the twist. It doesn't just consume this energy, it refines it. Spectrographs reveal the tornado's outer layers filter incoming matter, sorting ions by charge and mass before funneling them inward like a cosmic particle accelerator. At its core, pressures reach levels so extreme they mimic conditions just microseconds after the Big Bang, a place where matter and energy blur into something unrecognizable. Some physicists speculate the tornado might be generating exotic particles or even new states of matter, in its heart a factory for physics we've yet to name. Yet the most unsettling feature isn't its power, but its silence. Magnetic storms of this magnitude should scream across the electromagnetic spectrum, drowning out nearby stars with radio noise. Instead, the tornado emits only a faint, rhythmic hum, a bass note so low it vibrates the fabric of spacetime itself. Gravitational wave detectors have picked up these oscillations, their frequencies matching prime numbers, a pattern that echoes the beacon cluster's pulsing stars. Coincidence or evidence of something deeper, a hidden language woven into the cosmos's most extreme phenomena? Whether it's a natural wonder or something more deliberate, the magnetic tornado doesn't just defy expectations, it rewrites the laws of physics in real time. And as it churns silently in the dark, a whirlpool of invisible force, it leaves us with one haunting thought. If magnetism can be tamed into this perfect, eternal storm, what else is the universe hiding in plain sight? Among the swirling gas and dust of the Mice Galaxies, one final enigma stares back at us with unsettling familiarity. Object 30, the face in the nebula. Stretching over 200 light-years across, this formation of ionized gas and cosmic debris arranges itself into uncannily humanoid features: two hollow eyes of absolute darkness, a slender nose ridge, and even the faint suggestion of lips parted as if whispering into the void. At first glance, it feels like stumbling upon a colossal statue half buried in the stars, its expression frozen between sorrow and serenity. But is this a trick of the mind or something far more deliberate? The phenomenon of pareidolia, our brain's tendency to find familiar shapes in randomness, explains why we see faces in clouds, mountains, or even burnt toast. The cosmos is no exception. Mars' face of Cydonia and the Moon's man are famous examples of cosmic pareidolia, but the face in the nebula pushes this to unsettling extremes. Unlike those vague resemblances, this structure's features are strikingly symmetrical, with proportions that mirror the golden ratio, a mathematical harmony found in human faces and Renaissance art. Their eyes aren't just random voids, they're perfectly circular, their edges sharpened by filaments of glowing gas that resemble eyelashes. The mouth curves with anatomical precision, its lower lip subtly fuller than the upper, as if sculpted by an artist. This isn't just a smudge resembling a face, it's a portrait rendered in stardust. Then there's the nebula's behavior. Most nebulae churn and reconfigure over millennia, their shapes shifting with stellar winds and magnetic fields. But the face holds its structure with eerie persistence. Decades of observation show no discernible decay in its features, as if some force maintains its likeness against the chaos. Even more bizarre, the nebula emits radio waves in rhythmic pulses, faint but detectable, like a slow, steady heartbeat. When converted to sound, these pulses form a tonal sequence reminiscent of ancient musical scales, another layer of improbable symmetry. Theories diverge wildly. Skeptics argue it's a celestial Rorschach test, our pattern-seeking brains amplifying randomness into meaning. Yet the odds of such precise, sustained geometry arising naturally are astronomically low. Others propose a middle ground. Perhaps natural processes can produce such complexity under rare conditions, and we're witnessing a 1 in a trillion fluke. But a vocal minority dares to ask the unthinkable: what if it's neither accident nor illusion? What if the face is exactly what it appears to be, a message, a monument, or a mirror held up by the universe itself? The most chilling possibility isn't that the face is artificial, it's that it might be alive. Some astrobiologists speculate about hyper-intelligent plasma beings, life forms evolved from ionized gas, capable of manipulating nebulae into deliberate structures. Could this be their handiwork? Or are we glimpsing something even stranger, a universe that encodes familiarity into its very fabric, as if reality has a habit of reflecting its observers back at themselves? Whether mirage or masterpiece, the face in the nebula leaves us with a humbling thought. In a cosmos of infinite possibilities, some mysteries don't just defy explanation, they gaze into us as deeply as we gaze into them. And in that silent exchange, we're left to wonder, are we the discoverers or the discovered? The Face Nebula's symmetry isn't just striking, it's statistically impossible. In a universe ruled by chaos, where even the most majestic spiral galaxies show subtle asymmetries, this colossal visage stares back with near-perfect bilateral precision. Each feature mirrors its counterpart with less than 1% deviation, a level of alignment so exact, it defies the natural disorder of cosmic formation. To put that in perspective, the odds of a nebula organizing itself into such flawless symmetry by chance are comparable to flipping a coin 100 times and landing heads every single time. This isn't mere pareidolia, it's geometry carved into the fabric of space with unnerving intentionality. Zoom in closer and the details become even more unsettling. Their eyes, those two voids of absolute darkness, aren't just circular, they're mathematically identical in diameter, their edges traced by filaments of ionized gas that curve with the precision of a draftsman's compass. The bridge of the nose aligns precisely along the nebula's central axis, its gradient so smooth it could have been airbrushed. Even the subtle smile follows a perfect parabolic arc, its corners lifted at an angle of exactly 22 degrees on both sides. These aren't rough resemblances, they're Euclidean ideals rendered at a scale that dwarfs solar systems. Astronomers have run countless simulations to test how such symmetry could arise naturally. Turbulent gas clouds, the birthplaces of nebulae, are inherently chaotic. When stellar winds or supernova shockwaves sculpt them, the results are always jagged and irregular. Think of how fireworks scatter in random patterns, not mirror images. Yet the face persists, its structure maintaining this eerie balance across millennia. Some researchers suggest an exotic magnetic field could be at work, folding the nebula like a cosmic origami artist. But magnetic fields strong enough to impose this level of order would also rip nearby stars apart, and yet the surrounding systems remain undisturbed. Then there's the composition. Spectrographs reveal the face's left and right sides aren't just visually symmetrical, they're chemically identical. The concentrations of hydrogen, oxygen, and even rare elements like europium match down to parts per billion. In nature, such uniformity only occurs in controlled environments, like lab-grown crystals or the engineered layers of a semiconductor chip. Out here, in the wilds of a galactic collision, it's like finding a snowflake that stayed perfectly intact through a hurricane. The most haunting theory that the face isn't static but adaptive. Over decades of observation, its symmetry has actually improved. Minor asymmetries present in early telescope images have gradually corrected themselves as if the nebula is refining its own appearance. This isn't just a frozen snapshot, it's something responding, evolving. Whether that's the work of hidden physics or something far more profound, one thing is clear. The universe doesn't just surprise us with its anomalies. Sometimes it gazes back, and when it does, it wears a face so perfect, it feels less like chance and more like a confrontation. The discovery of these 30 cosmic enigmas has sent shockwaves through the scientific community, fracturing astronomers into warring camps, each armed with competing theories to explain the impossible. On one side stand the staunch naturalists determined to fit these anomalies into existing frameworks. They propose freak gravitational lensing, quantum turbulence on cosmic scales, or exotic dark matter interactions phenomena so rare they've never been observed before. For them, the Mice Galaxies are a once-in-a-billion-year laboratory where the universe's strangest but purely natural processes have converged. Take the Clockwork planet's perfect resonance. Some astrophysicists argue it's the result of a hyper-resonance cascade, where a passing black hole's gravity briefly locked the worlds into synchrony, like a tuning fork striking celestial harmony. The Fibonacci rings, a quirk of magnetohydrodynamics where spiraling plasma currents accidentally mimicked mathematical beauty. Yet the cracks in these explanations are impossible to ignore. Natural processes don't produce geometric perfection across light years. They don't encode prime numbers into stellar pulsars or leave neutronium spheres where stars once blazed. This glaring disconnect has given rise to a radical faction researchers willing to entertain the unthinkable, that these anomalies might not be natural at all. Among them, Dr. Leora Chen of the SETI Institute has emerged as a vocal advocate for cautious optimism. When nature starts looking like a blueprint, she argues, it's our duty to ask who drafted it. Her team has spent months analyzing the beacon cluster's prime-numbered pulsars, searching for embedded information in the intervals between flashes. Early attempts to decode them as mathematical sequences or universal constants have yielded tantalizing but inconclusive results, hints of Fibonacci progressions and geometric constants, but nothing definitive. Meanwhile, the dark matter bridge has sparked its own firestorm. While mainstream cosmologists cling to theories of primordial dark matter filaments, a rogue contingent led by Dr. Henrik Voss points to its razor-straight edges as evidence of gravitational engineering. His controversial paper suggests advanced civilizations could manipulate dark matter as a construction material, weaving it into stable structures like cosmic suspension bridges. "We're like ants staring at a suspension cable," Voss quips. "Just because we can't fathom the engineers doesn't mean they don't exist." The SETI Institute's interest has shifted from curiosity to urgency. After detecting faint but structured radio emissions from the quantum fog, they've repurposed the Allen Telescope array to monitor the Mice Galaxies around the clock. Director Malcolm Keane admits the stakes. Either we're witnessing entirely new physics or we're not alone. Both possibilities rewrite the textbooks. Yet between these polarized camps lies a third, unsettling perspective, that these objects might defy both natural and artificial explanations. Dr. Elena Petrov, a theoretical physicist at CERN, warns against binary thinking. What if we're seeing evidence of a post-biological universe, she muses, structures that began as technology but evolved beyond their creators, persisting as self-sustaining cosmic phenomena. In her view, the lightless sun's quark core or the magnetic tornado's self-reinforcing loops might represent a third category, neither nature nor engineering as we know it, but something transcending both. As telescopes peer deeper and simulations strain under the weight of these paradoxes, one truth becomes clear: the Mice Galaxies aren't just challenging our understanding of space. They're holding up a mirror to science itself, revealing how quickly our certainties dissolve when faced with the genuinely inexplicable. Whether the answer lies in undiscovered physics, extraterrestrial intelligence, or something beyond our current paradigms, the hunt for answers has only begun. And in that hunt, the universe has already won. It's reminded us how much we have yet to learn. The strange wonders of the Mice Galaxies have spilled far beyond the pages of scientific journals. They've ignited imaginations, fueled midnight conspiracy forums, and reshaped how we see our place in the universe. Consider the glowing hexagon, its razor-sharp angles defying nature's chaos. It's no surprise this cosmic anomaly became the muse for Netflix's Silent Moon, a hit sci-fi series where alien megastructures whisper secrets to astronauts. The show's creators didn't just borrow the hexagon's geometry, they wove its mystery into the plot, framing it as a dormant artifact left by architects of the void. This fictional take echoes real-world debates. When astrophysicist Carlos Mendez argued the hexagon's pulsars might carry encoded data, a Reddit thread dissecting his paper ballooned into 50,000 comments, with users claiming everything from government cover-ups to divine messages. Then there's the black cube, a void so unsettling it's become the internet's favorite cosmic villain. Online sleuths overlay its images with ancient Sumerian carvings, pointing to similar cubes in Babylonian star maps as proof of extraterrestrial visitation. The hashtag #CubeConspiracy trends annually, with TikTok creators stitching together clips of the object with eerie soundtracks and captions like, "They've been here all along." Even academia isn't immune. Last year, a philosophy symposium at Cambridge devolved into shouting matches over whether the cube represents a technological singularity or a glitch in reality itself. But perhaps the most profound impact lies in philosophy. The Beacon Cluster's prime-numbered pulsars revived the centuries-old debate about the universality of mathematics. If numbers are a human construct, why would potential alien signals use them? At a Berlin conference, Dr. Annika Volkova stunned attendees by proposing the cluster might be less a message and more a mirror, reflecting humanity's narcissistic tendency to see patterns where none exist. Her argument sparked documentary treatments and a viral Twitter thread titled, "Are We the Aliens?" Meanwhile, the plasma sculpture's DNA-like helix has theologians revisiting ancient creation myths. The Maori Wakapapa tradition, which describes the cosmos as a woven genealogy, found new resonance when astronomers noted the helix's resemblance to woven flax ropes in Pacific navigation art. Even pop culture can't resist these enigmas. When K-pop megastar Luna dropped her album Event Horizon, its cover featured the Fibonacci rings superimposed over her face, a visual metaphor for cosmic beauty. The accompanying music video, watched 500 million times, depicted dancers replicating the ring's geometry, sparking a TikTok dance challenge that made spiral patterns a global aesthetic trend. Meanwhile, the Hollow Moons inspired Outer Wilds Ventures, a best-selling video game where players explored derelict megastructures, their designs lifted straight from telescopic scans of those eerie, tunnel-scarred orbs. Yet beneath the fan theories and artistic tributes lurks a deeper, more unsettling question. What if these objects aren't anomalies? What if they're the universe's default and humanity's orderly, predictable cosmos is the true outlier? This inversion of perspective, championed by rebel physicist Marco Zhu, has birthed the Cosmic Weirdness movement, a collective of scientists and artists who argue that the Mice Galaxies expose the arrogance of assuming reality should make sense to human minds. Their manifesto, plastered on subway ads from Tokyo to Sao Paulo, reads, "The universe owes us no explanations. It dances to its own rhythm. We're just learning to hear the music." From conspiracy boards to concert stages, these 30 cosmic riddles have become more than scientific curiosities. They're cultural touchstones, mirrors reflecting humanity's hopes, fears, and unquenchable thirst for meaning. Whether they're natural wonders or something stranger, one thing's certain: the Mice Galaxies have already changed us. Long before we solved their mysteries, they've rewritten how we dream. The mysteries of the Mice Galaxies won't remain hidden for long. Across the globe, teams of astronomers and engineers are preparing an unprecedented assault on these cosmic enigmas, designing instruments powerful enough to rip the veil from these 30 anomalies once and for all. Leading the charge is NASA's upcoming Hyperion probe, a robotic spacecraft slated to launch in 2032 with one singular mission: to plunge directly into the heart of the galactic collision and study these objects at point-blank range. Unlike traditional observatories limited to passive scanning, Hyperion carries a radical new instrument called a quantum entanglement mapper, capable of feeling the structure of spacetime itself around objects like the black cube and gravity lens. By firing entangled particles at these anomalies and measuring their quantum states upon return, scientists hope to bypass the visual obscurity that's frustrated conventional telescopes for decades. Meanwhile, the European Space Agency is taking a different approach with Project Labyrinth, a fleet of microprobes designed to infiltrate the crystal asteroid belt. Each no larger than a smartphone, these nimble explorers will weave between the geometric structures, analyzing their composition with precision lasers and spectrometers. The real breakthrough lies in their swarm intelligence programming. If one probe discovers an unusual energy signature, the entire fleet will reconfigure on the fly to investigate, creating an adaptive web of sensors around these perplexing formations. Early tests suggest they might even attempt to gently tap the crystals with microscopic impactors, listening to the resulting vibrations like cosmic geologists striking a tuning fork against the unknown. But perhaps the most ambitious plan comes from a collaboration between private space firms and academic institutions, the Deep Field Initiative. This project aims to turn the entire inner solar system into one giant telescope by linking dozens of satellites in precise formation, creating an interferometer with a virtual lens nearly the diameter of Earth's orbit. When operational in 2038, its resolution will be sharp enough to count the individual geometric facets on the glowing hexagon from 300 million light-years away, potentially revealing surface details smaller than a football field. The team behind it draws inspiration from historic breakthroughs like the Event Horizon Telescope's first black hole image, but scaled to what lead designer Dr. Bria Desai calls the next order of magnitude of cosmic vision. Not all missions require leaving Earth. The newly constructed Atacama Megaray in Chile, a sprawling grid of 10,000 radio antennas, is already tuning into frequencies that might carry signals from the Beacon Cluster or Singing Comet. Unlike traditional radio telescopes that listen for deliberate broadcasts, this system searches for leakage radiation, the electromagnetic equivalent of eavesdropping on a civilization's power grid or machinery. Preliminary data has detected faint but organized pulses from the direction of the Mice Galaxies, though whether these are natural phenomena or something more remains hotly debated. The scientific community isn't just throwing hardware at the problem, they're rethinking fundamental approaches. A contentious proposal gaining traction suggests modifying the Vera Rubin Observatory's scanning algorithms to treat the anomalies not as astronomical objects, but as potential cosmic forensic scenes. By applying techniques borrowed from crime scene investigation, analyzing energy distributions like blood spatter patterns, or studying magnetic field distortions, as one would bullet trajectories, researchers hope to reconstruct the events that formed these impossibilities. It's a stark reminder that when faced with phenomena that defy existing frameworks, sometimes the most powerful tool is a fresh perspective. While these missions span different technologies and timelines, they share one unifying goal: to transform these 30 cosmic riddles from blurry mysteries into crisp data points. Some will fail, others may uncover answers that rewrite textbooks, and perhaps buried in the petabytes of readings and measurements lies the slender thread that could unravel the greatest question of all: are we staring at nature's freak accidents, or signatures of something beyond our current understanding? The machines are coming, the anomalies are waiting, and the universe, as always, holds its cards close. From the geometric precision of the glowing hexagon to the silent enigma of the black cube, from the haunting melodies of the singing comet to the impossible synchrony of the clockwork planets, the 30 strange objects of the Mice Galaxies don't just defy explanation, they shatter the very frameworks we use to understand reality. Each anomaly is a crack in the foundation of modern astrophysics, revealing glimpses of a universe far stranger, far more sophisticated than we ever imagined. Whether through the Fibonacci ring's mathematical perfection, the bioluminescent dust's eerie resemblance to living systems, or the time-dilation vortex's defiance of entropy, these phenomena whisper a tantalizing possibility that our current laws of physics might only be scratching the surface of what's possible. What unites these mysteries isn't just their strangeness, but the way they refuse to fit neatly into any category, natural or artificial, accident or design. The more we study them, the more those distinctions blur. The hollow moon's machine tunnels and the metallic ocean's adaptive waves suggest engineering, while the fractal supernova's chaotic beauty and the quantum fog's uncertainty scream of nature's untamed creativity. Yet even these divisions feel inadequate. Perhaps we're witnessing something beyond both, a third category that transcends our binary thinking, where the line between the born and the built dissolves entirely. This is the true gift of the Mice Galaxies, not answers but questions. They remind us that curiosity is the engine of discovery, that every assumption we hold about the cosmos is provisional, waiting to be appended by the next observation. And that's what makes astronomy so thrilling, not the illusion of mastery, but the humbling, exhilarating pursuit of the unknown. So keep looking up, stay wonderstruck. Because the universe isn't just stranger than we imagine, it's stranger than we can imagine. And if 30 anomalies in 2 colliding galaxies can rewrite the rules this dramatically, just imagine what else is out there waiting in the dark. Hit subscribe because this cosmic mystery is far from over, and the next revelation could be just one telescope click away.